Investigating, illuminating, and inspiring. Texas is home to some of the world's brightest innovators. Tonight, the Academy of Medicine, Engineering, and Science of Texas honors 5 up-and-coming researchers with the 2011 Edith and Peter O'Donnell Awards. Margaret Goodell, Medicine.
So is this for the gel for the PCR?
Yes, this is for the PCR product.
For Margaret Goodell, every day in her lab could bring a life-saving discovery.
It'll be very exciting to see these results.
Oh yeah, that'd be very exciting.
Peggy is a pioneer in the study of bone marrow stem cells, those amazing cells that regenerate themselves and rejuvenate aging tissues. She's the director of the Stem Cell and Regenerative Medicine, or STAR Center, at Baylor College of Medicine in Houston.
Anything that we understand or about stem cells, or anything that we discover that can allow us to manipulate stem cells, has the potential to impact all different kinds of blood diseases.
Peggy was born in Ohio into a scientific family. Her father was an engineer and her mother a nature lover. Also motivating Peggy was her grandmother.
She thought maybe science would be an interest of mine, and so she started sending me books on how to dissect frogs, which I did in the backyard.
Years later, Peggy would travel to Connecticut and London to earn her bachelor's degree in biology. She received her PhD from Cambridge. For her postdoctoral work, Peggy chose a new field that was showing lots of promise: bone marrow stem cells.
The idea was that if we could take out the stem cells of the bone marrow and modify them, we could put them back into patients and treat blood diseases.
It didn't take her long to make an impact. In 1996, she developed a process for harvesting high-quality populations of stem cells for research, an innovation that's still used today. The next year, she came to Baylor College of Medicine to open her lab. The breakthroughs continued. Peggy and her team discovered bone marrow stem cells play an important role in our immune system.
This allows replacement of all of the components that you need and allows for a very healthy immune response.
Now, her team is trying to understand that role and whether the failure of those stem cells could cause diseases like leukemia and lymphomas.
Those are the colonies.
Colonies look bigger here.
Stem cell research is still a new frontier, and Peggy makes sure her team upholds the highest scientific standards.
Her work in bone marrow stem cells has been very cautious and very highly respected.
When some scientists speculated that stem cells hold a fountain of youth because of their ability to regenerate tissues, Peggy's team investigated. They discovered that bone marrow stem cells also experience the effects of aging.
We still hope that if we can understand how they age, that we might at least be able to slow their aging process down.
Peggy Goodell has become known as a leader in her field, and that is helping to establish Baylor as a top research institution.
Someone like Peggy, for me, is Baylor's star in the stem cell area. She's growing a team in the stem cell area, not only her own research program, but other faculty members that she's helped to recruit.
For Peggy Goodell, it's not as much about personal gain as it is gaining an edge against maladies like sickle cell anemia and AIDS.
We are constantly aware of the potential impact that our work can have on areas of medicine. And that's very exciting and motivates our work.
J.C. Chow, Engineering.
Electromagnetic wave have to go through all the ribs and tissues.
Dr. J.C. Chow is describing an electronic device designed to be implanted in the human body. It's not science fiction. It's actually a new wave of medicine being developed today in his lab at UT Arlington. JC hopes these devices will one day help make diseases and chronic pain more bearable.
Engineer can bring a solution to the medicine in a total different perspective.
Drawing from his expertise in electrical engineering and a knack for listening to medical doctors, JC is seeking out new approaches to treating old health problems.
His collaborative nature
is really important in helping him learn and understand where important problems are. And then he's able and creative enough to take his own discoveries and to make them useful.
JC grew up in Taiwan as the son of an electrical engineer. He earned degrees in electrical engineering at Taiwan University and at Caltech. After college, JC found work at various corporate labs. He soon realized he'd rather spend his time solving the problems of mankind than worrying about profits. That's what led him to UT Arlington in 2002.
Every time the acid or non-acid liquid flush through the esophagus, the impedance sensor will detect it.
At UTA, JC and his students are developing a radio frequency sensor that, when implanted in the esophagus, can detect whether drugs are effectively treating severe acid reflux that can lead to cancer. The sensor works without batteries or wires.
And we also have the device that's embedded in the stomach that can provide electrical current to stimulate the stomach tissue.
There's even a batteryless strain sensor that can detect esophagus wall pressure or bladder volume. JC's team is collaborating with another professor to develop sensors called neurostimulators. They're designed to detect pain signals and then block them by transmitting electrical signals into neurons,
which is much more efficient with much less side effect than conventional way like morphine.
In yet another part of JC's lab, they're working on a microfluidic platform that shows how prostate cancer cells move and grow.
You see, this cell is moving in two different directions. Yeah.
While many of his devices are in development or trial phases, JC already has group members in the clean room at UTA developing mass production processes in anticipation of future FDA approval. And JC looks forward to those approvals. As a lifelong diabetic, he knows the pain and discomfort disease can cause.
I feel very happy whenever we have some research result that can go into clinical use. I feel a personal accomplishment knowing I help a lot of people.
Kim Orth, Science.
So now you're going to try to do it without centrifuging and just see what happens when they infect.
Yeah.
Dr. Kim Orth's interest in bacteria is infectious. She and her students at UT Southwestern Medical Center in Dallas spend countless hours studying the germ.
It excites me that we can discover new things by studying bacteria because they figured it out so long ago.
What they figured out was how to manipulate the signaling system in our cells, the system that triggers our disease-fighting defenses.
They basically hit the Achilles heel in a signaling pathway, and they can shut the whole pathway down.
Kim believes if we can learn to manipulate cells the way bacteria do, the possibilities could be enormous. A native of Plano, Texas, Kim had no real interest in biochemistry until college. She took a class at Texas A&M on molecular genetics, and the professor ignited a spark.
I'd always learned biology and chemistry and genetics. And he took them all and he melded them all together, and I thought, this is amazing.
Kim earned her bachelor's degree in biochemistry, then her master's from UCLA and her PhD from UT Southwestern. Kim was working on her postdoc at the University of Michigan when she made an amazing discovery. She found that the bacteria that cause bubonic plague spread by sending what she describes as targeted missiles into cells. Those so-called missiles prevent proteins in the cells from sending out signals for help. Kim compares it to taking control of the light switches in a house.
So the bacteria turns off all the switches so that the cell can't change shape and can't engulf the bacteria, right? And so we figure out what those switches are, and in doing so, we figured out new switches.
Those new switches represent previously unknown ways in which our cells work. Impressed by her discovery, administrators at UT Southwestern asked Kim to open a lab on their Dallas campus to continue focusing on her promising research.
She's laying the groundwork for our understanding of how bacteria cause disease, That understanding is essential for the eventual development of therapeutics, treatment of a number of diseases caused by bacterial infections.
They shouldn't be able to bind because they'll take off the fibronectin.
The breakthroughs have continued. For instance, Kim and her researchers have discovered how bacteria in shellfish destroy cells in the human body.
I think Kim's work is pioneering and creative. She's used a multidisciplinary approach that's included biochemistry, cell biology, structural biology, and infectious disease. And she has opened up a whole new area of our understanding of bacterial pathogenesis. And her work has brought enormous attention to our institution.
Kim believes she couldn't be working in a better place.
There's so many experts on so many parts of the cell that you can have wonderful collaborations with many different scientists. What's really important right now is that we keep investing in basic research, because if we don't, then we won't be able to make the tools for medicine later. I feel so lucky that I've been supported by people in order to do this basic research.
David Fuller and Duncan Hudson, Technology Innovation.
If that's the case, then if you take this path, which we can connect today.
Duncan Hudson and David Fuller are creating more uses for LabVIEW, the flagship product for Austin-based National Instruments. Their work is a big reason why LabVIEW is the most widely used graphical programming language in the world. They have ensured the same paradigm can be used for applications for kindergartners and rocket scientists.
This is the most work, next-gen runtime.
David and Duncan's leadership and vision are helping engineers and scientists design, prototype, and deploy their innovations more efficiently. Rather than taking time to map out their programs with lines of text, LabVIEW users connect icons and arrows to resemble a flowchart. David and Duncan designed the software to match the way programmers think.
Part of the magic of LabVIEW, I think, has always been that it fits usually the mental model of the engineer.
With David and Duncan leading the entire global research and development teams, LabVIEW became more versatile. Its graphical programming could be used for the deployment of software embedded onto chips, also for communications design.
We're really trying to create a language by computer scientists for non-computer scientists.
Their love for science started early. Like most boys, David enjoyed computer games, but not just playing them, also programming them.
By the time I actually entered college at Texas A&M, I had a pretty strong background in both the math, the logic, and a history of computer architectures.
As a boy, Duncan Hudson had dreams of winning a Nobel Prize for chemistry. But at UT Austin, he chose computers over chemicals. Duncan and David both wanted to use their programming expertise to make a difference in the world. That's why they came to National Instruments in '92 and '95.
The potential that I saw in LabVIEW, and actually what could already be done, was steps ahead of the cutting edge, I thought, research that I was doing at the university.
The software is used to develop medical innovations, create industrial robots, and even control the CERN Hadron Collider.
Seeing applications, some of them are just mind-boggling. Thought-controlled wheelchair invented at University of Illinois.
A car for the blind from Virginia Tech.
Yeah.
We're not the expert that knows how to measure carbon emissions in the rainforest, but we enable that guy. And it's their community and their IP that is truly making the world a better place, and we're just making that happen faster.
Duncan and David's teams have developed software add-ons, modules, and toolkits, so the software can be used by scientists and engineers in different disciplines working at more than 30,000 companies.
Both David and Duncan have very good technical skills. When you combine that with their ability to lead people, makes them very effective as leaders for our LabVIEW project.
David and Duncan also led the way as NI developed Lego robotics software for kindergarten through high school to train the next generation of LabVIEW users.
When LabVIEW and NI are positively impacting the education and career of every engineer and scientist on the planet. That would be, to me, the ultimate end goal. It's ridiculously audacious. That's what we're aimed at.
Congratulations to all of this year's winners of the Edith and Peter O'Donnell Awards.